Okay, so today we're going to talk about applications of vectors. And this is given my scenario, so you might want to pause the video and just write this problem down for a second. Monica throws a javelin in a track meet while running 4 meters per second. She throws the javelin with a velocity of 28 meters per second at an angle of 48 degrees. First, you need to be able to find the components of each vector, what the runner is doing and what the javelin is doing. So what the runner is doing, it's moving 4 meters per second on the ground. So that means the runner would just be going this direction. That would be the vector that describes the runner. So I'm going to put an R, and that's going to be 4 meters per second. So for my runner, they're going to be moving 4 to the right, up or down nothing. So 4, 0 is that runner. For the javelin, so if you're comparing it to the ground, this would be the ground, but the javelin is creating an angle of 48 degrees with the ground, and it's being thrown at an angle of 48 degrees at a velocity of 28 meters per second. So what we know about the javelin is we know the velocity and we know the angle. So to find the components of the vector for the javelin, what we have to do is we have to take 28 and multiply it times the cosine of 48 to find your A value. So it's 28 times the cosine of 48. And to find the B value, you have to take 28 and multiply it times the sine of your angle 48. Okay, so you're going to put those in the calculator. So let me find my calculator. And when you input those values, you're going to get 18.7 and 20.8. So this would be my vector J for my javelin, and I have vector R for my runner. Okay, to find the resultant vector, you're just going to take your two vectors that you have and add them together. So your resultant is going to be just your runner plus the javelin. So if I'm adding these values together, 4 plus 18.7, it's going to be 22.7. And my B values, 0 plus 20.8, 20.8. So my resultant should be 22.7 and 20.8. That's the runner and the javelins thrown combined together. All right, so then it asks you to find what is the speed of your javelin and the runner together, traveling together. So the speed of your resultant vector. So if I go back to what my resultant vector is, I have its components. To find the speed, remember that's just your magnitude. So that is going to be the square root of your A squared plus your B squared. So 22.7 squared plus the 20.8 squared. If any of these values are negative, make sure you put them inside the parentheses before you square them. So if you put that in your calculator, you're going to get 30.8. The label on this is meters per second for the speed. Okay, last we have to find the direction. So remember that's your theta, and your formula for that is theta equals the inverse tangent of B over A. So in this case, I'm using the resultant vector, and so I'm going to take the inverse tangent of my B value, 20.8, divided by my A value, 22.7. So if you put that in the calculator, you're going to end up with 42.5 degrees. And so the angle that the javelin will be thrown is 42.5 degrees if the runner is running with it at its speed of 4 meters per second. Okay?